So for these, I would want you to look on page 554, have the list in front of you to work on these. So classify as nonpolar, polar. If polar, indicate the R group is neutral, acidic, basic. Indicate of each would be hydrophobic, hydrophilic. The R group in valine consists nonpolar amino acid, hydrophobic. Hydrophobic is not loving water, hydrophilic loving water. Polar amino acid, neutral, hydrophilic. So you have all this information on page 554. Classify amino acid histidine as polar and nonpolar. So where is histidine located on page 554? I see it as a basic amino acid with a charged R group, HIS. Nonpolar, polar, what is that? Polar amino acids with a charge, neutral, acidic, basic, hydrophobic, hydrophilic. So please go ahead and look up this information on page 554, polar, nonpolar, neutral, acidic, basic. It's a basic amino acid. If it would be hydrophobic or hydrophilic. It would be hydrophilic because of the polar nature of the R group. Structural formulas of amino acid draw the ionized form of the amino acid, serine and aspartic acid. So there is all these amino acids are on page 554. So you can pick up the structure and draw the structures of amino acids. Okay. So aspartic acid is acidic with negative charge. It has a charged R group. And now there it is, acidine and aspartic acid, amino acid. 3-letter and 1-letter abbreviation, leucine, again 554. I'm looking at leucine. And it is on page 554, the LEULPI of 6.0 with a hydrophobic R group, nonpolar amino acid, leucine. Acidic, basic, state the overall change in glycine. So glycine, the PI of glycine is 6.0. So at a pH of 6.0, there will be no change in the glycine structure. The overall structure remains the same. At a pH of 8, 8 is basic. And in a basic situation, the NH3, the amino group, loses its positive charge, and the carboxylate group remains ionized. So it gives a negative charge at pH 8. Glycine has a negative charge at pH 8. So you can do the same for glycine. So go back to 554, get the structure of glycine, and look up the acids and bases on page 557 and predict the structure. Will it have a positive or a negative charge? Glycine at pH 3. So now, identifying a tripeptide, there are 3 amino acids in this tripeptide. So we have to identify the N-terminal, C-terminal. This is the N-terminal, this is the C-terminal, and this is the amino acid in the middle. So, and use the 3-letter, 1-letter abbreviation of amino acids to give the amino acid order and what is the name of the tripeptide. So the N-terminal is threonine 9 or threonine. Phenylalanine is the C-terminal. And leucine is the amino acid in the middle. So THR, LEU, PHE, or TLF. So the name will be threonyl leucyl phenylalanine. So we retain the C-terminal name. So we retain the name, and these two replace YL. The last couple of alphabet, threonine becomes threonyl. So you can set up a tripeptide with this amino acid sequence and give the name and the abbreviation, 3-letter, 1-letter abbreviation. What is the N-terminal amino acid? PRO is, what is the name of PRO? PRO is proline, so prolyl. HIS is histidine. HIS is histidine, histidyl. And what is MET? MET. I'm looking for MET. MET is methionine. So we retain methionine, and then we give the 3-letter and the 1-letter abbreviation. No, I will go past this. Okay, no, we are going back there. Okay, indicate whether the following conditions are responsible for primary, secondary, tertiary, quaternary. Disulfide bonds that form between protein portions of a protein chain, peptide bonds that form a chain of amino acids, hydrogen bonds between the hydrogen of peptide 4 amino acids away. So, do these interactions create primary, secondary, tertiary, quaternary proteins? So, disulfide bonds are type of interactions between R groups found in tertiary and quaternary level of protein. The peptide bonds in the sequence in a polypeptide chain form the primary level. Hydrogen between peptide bonds form the secondary level of protein, alpha, beta, triple helix. What structural level is represented by interaction to primary structural level? Did you see this? The insulin has a primary structure, and the 2 peptide chains are linked through the disulfide bond. So what structural level will be a tertiary or quaternary structural level of protein structure? 2 subunits of insulin. The chemical reaction aminotransferase, transfer of amino group. Lactate dehydrogenase, removal of hydrogen from lactate. Hydrolysis, lipase. So lipase enzyme, hydrolysis of lipid. Now you have urease enzyme. So does the effect of lowering the temperature to 10 degree have any rate reaction? Because 10 degree is lower than the optimum temperature of 37 degrees Celsius. It decreases the rate of the reaction. If urease has an optimum pH of 7.0, if you lower the pH to 3, it again decreases the reaction, as the optimum pH is 7. By lowering the pH, you're decreasing the activity. Enzymes are very sensitive to temperature and pH. State the type of inhibition. The inhibitor has a structure that is similar to the substrate, competitive inhibitor. An inhibitor binds to the surface, changing its shape in a way that cannot bind to the substrate. Non-competitive inhibitor. What type of inhibition occurs when serine, a nerve gas, forms a covalent bond? Irreversible inhibition. Irreversible inhibitor. Nerve gas, serine, is an irreversible inhibitor.